Next problem. In a meter bridge, the balance point is found to be at 39.5 centimeter from the end A, when the resistor Y is of 12.5 ohm. Determine the resistance of X. Part B. Determine the balance point of the bridge above if X and Y are interchanged. Now here they have given a meter bridge. This is the meter bridge. Now in the left gap there is a resistor X which is to be calculated. In the right gap there is a some Y resistor is connected. Okay. They have given the condition. Solution. Now in the first case, when Y is 12.5 ohms given, so Y is equal to 12.5 ohms. When Y is 12.5 ohms, he is getting a balancing point. L is equal to how much? 39.5. 39.5 centimeter. Let it be in centimeter. If this is so, then we have to calculate what is the value of X. What is the value of X that we are going to determine. Now since L is equal to 39.5, now if this is L from A, point A he has given, from point A, the balancing point is 39.5. Then what is this DC? Obviously DC becomes 100 minus L. So that is 100 minus of 39.5. Therefore 100 minus L is equal to, it is 100 minus 39.5. So that is equal to 60.5. So 100 minus L becomes 60.5. Now by applying the balancing condition of this Wheatstone network, we have the standard formula. It is R by S is equal to L divided by 100 minus L. Okay, that is the standard formula. In place of R, we are having X. In place of S, we are having Y. Okay, therefore X by Y is equal to L divided by 100 minus L, or we have to determine X is equal to L into Y divided by 100 minus L. Now substituting the values and simplifying is equal to, what is L here? Now L is 39.5 into Y, it is 12.5 divided by 100 minus L, that we have calculated 60.5. Therefore X is equal to, now take the calculator and work it out. So we have 39.5 into 12.5 divided by 60.5. That is equal to, I am getting 8.16. 8.16 ohm. 8.16 ohms. Value of X is 8.16 ohms. This is first part. Clear? Now the second part is B, that is, if determine the balancing point of the bridge above if X and Y are interchanged. If the values of X and Y are interchanged, what is the new balancing point? That means we have to calculate L. L we are going to calculate. If X and Y are interchanged, now here we are placing Y and here we are placing X. Okay. So X and Y are interchanged. Then what will be the condition? Now here we are getting Y. For the second case, I am getting here Y and here X for the second case. Therefore, Y by X is equal to L divided by 100 minus L. The new balancing condition becomes Y divided by X is equal to L divided by 100 minus L. That's all. Y value they have given 12.5 divided by X value, just we have calculated it, 8.16 is equal to L divided by 100 minus L. Now if you simplify this one, So 12.5 divided by 8.16. So that is equal to 1.53. I am getting 1.53 is equal to L divided by 100 minus L. Now cross multiplying that one, 100 into 1.53, it is 153 minus 1.53 into L, that is equal to, on the right hand side we are having L. So therefore 153 minus 1.53 L is transferred to the right hand side and it is added to L. Therefore I will get 2.53 L, or L is equal to 153 divided by 2.53, or L is equal to, let me work out that one, 153 divided by 2.53. So value is equal to 60.47. 60.47 centimeter or 60.5. We can take it as 60.5, similar to that one. Therefore, L is equal to 60.5 centimeters. Then 100 minus L is then obviously 39.5 centimeters. Here, in the first case, balancing length is 39.5. and 100 minus L is 60.5. When we interchange the resistors, these two, L and 100 minus L, they are also getting to interchange. So here we are getting L is 60.5, 100 minus L is 39.5. So that is the meaning. Clear? Now what happens if we interchange the galvanometer and the battery? What happens if you interchange the galvanometer and battery? In the case of a meter bridge or Wheatstone network, if we interchange the galvanometer RM and the battery RM, then there is no change in the balancing condition. The balancing condition remains the same. And one more thing, we are having a thick metal strip. What is the use? That we have already told it in the theory classes. We are using thick metal strips so that its resistance becomes very small. As area increases, the resistance of that metal strip becomes smaller and smaller, so that it could not contribute to the total resistance. Its resistance should not be considered. Because of that reason, we are having a thick metal strip. Next problem. A storage battery of EMF 8 volts and internal resistance of 0.5 ohms is being charged by a 120 volt DC supply using a series resistor of 15.5 ohms. What is the terminal voltage of the battery during charging? What is the purpose of having a series resistor in the charging circuit? So, on battery ಇದೆ, ಅದರ EMF 8 ವೋಲ್ಟ್, ಬ್ಯಾಟರಿ ಲೋ ಆಗಿದೆ, ಬ್ಯಾಟರಿಯನ್ನು ಚಾರ್ಜ್ ಮಾಡಬೇಕು. For that one, we are using a DC supply of 120 volt. Now that is as shown in the diagram. Now this is the battery which is low, that we are going to charge it by using a DC supply of 120 volts. Now this battery has an internal resistance small r, that value is given 0.5 ohms. Clear? And this is charged through a series resistor capital R. Its value is given, it is 15.5 ohms. Okay. In that case, during charging, what is the drop across these two terminals? That is terminal voltage across the battery. Okay, that we have to work out. And second one, what is the purpose of having a series resistor? Now solution, we will work out. What are the given thing? EMF of the DC is given. If I take E1 is the EMF of the DC supply, that is 120 volt, and EMF of the battery which is to be charged is given, that is 8 volts, and its internal resistance is given, small r is equal to 0.5 ohm. Okay, and it is charged through a series resistor. Its value is given, capital R is equal to, so it is 15.5 ohms. Okay, Now we have to work out what is the terminal voltage. For that one, I have to calculate what is the current flowing through the circuit. ಚಾರ್ಜ್ ಮಾಡಬೇಕಾದ್ರೆ ಬ್ಯಾಟರಿನ ಚಾರ್ಜ್ ಮಾಡಬೇಕಾದ್ರೆ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತದೆ ಹೇಳಿ. Now before that one, look at the diagram carefully. While charging, we are connecting positive of DC to the positive terminal of the battery which is to be charged. ಯಾವ ಬ್ಯಾಟರಿ ಚಾರ್ಜ್ ಮಾಡಬೇಕಾಗಿದೆಯೋ ಅದರ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಅನ್ನ ಡಿಸಿ ಸಪ್ಲೈಯ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. Then it is a series combination. In series combination, we have studied, we have to calculate what is the equivalent EMF. Now here, while deriving the expression, we have taken the current from positive of one battery is flowing towards the negative of the another battery. That was the case. That I will write the diagram. We have taken like this. While obtaining an expression for equivalent EMF when two cells are in series, we have connected like this. So positive of the second battery is connected to negative of the first battery. But here is the case is different. The two positive terminals are interconnected. If that is the case, then what is the effective EMF? E equivalent becomes minus, because since the current is flowing here, now this EMF only current henge hogta ide nodi, current inside the cell is flowing from positive terminal to the negative terminal. Now that we have that EMF is taken as negative, that we have known. So therefore equivalent EMF is, it is E1 minus E2. It is not plus, it is minus. Okay, so it is E1, it is 120 minus E2, it is 8. Therefore equivalent EMF in the circuit when it is charging, equivalent EMF in the circuit when the charging starts is 112 volts. That is the equivalent EMF. Then what is the total resistance in the circuit? The total resistance it is simply R plus R. Clear? Therefore what is the current? Current during charging. Simple expression, current is equal to equivalent EMF divided by R plus R. Equivalent EMF is 112 divided by 15.5 plus 0.5. Now that is equal to 112 by 16. So 16 ones are 16, 16 sevens are 16 ones are 16 sevens are. Seven amps of current is flowing in the circuit. Clear? Next, since 7 amps of current is flowing, what is the potential drop across the external resistor? PD across R, potential drop across the external resistor. If I take this as I is equal to, so V is equal to I into R. V is equal to I into R. Now I is 7, current is 15.5 to 7. So multiplying this one, therefore potential drop across the external resistor, it is 108.5 volts. We are using 120 volts by DC supply and it is used to charge the battery. While charging we are using a series resistor. The voltage drop across the series resistor is 108.5. Then what is the voltage drop across the battery? Now that voltage drop is terminal potential. That is what is asked. Terminal voltage of the battery. Therefore terminal voltage of battery, it should be is equal to, now we are supplying 120, total is 120 minus, now here is this much 108.5. So therefore terminal voltage across the battery is equal to 11.5 volts. 11.5 volts. Okay, clear? 11.5 volts. Now look here, it is a different case. Battery voltage 8 volt ಇದೆ, ಆದರೆ ಬ್ಯಾಟರಿ ಅಕ್ರಾಸ್ ಅಲ್ಲಿ ಟರ್ಮಿನಲ್ ವೋಲ್ಟೇಜ್ 11.5 ಬರ್ತದೆ. ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ EMF ಜಾಸ್ತಿ ಇರ್ತಾ ಇದ್ದ, ಟರ್ಮಿನಲ್ ವೋಲ್ಟೇಜ್ ಕಡಿಮೆ ಇರ್ತಾ ಇದ್ದ. ಬಟ್ ಈ ಕೇಸಲ್ಲಿ EMF ಕಡಿಮೆ ಇದ್ದಾನೆ ಇದರದ್ದು, ಬಟ್ ಟರ್ಮಿನಲ್ ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ. ವೈ? ಹಿಯರ್ we are charging this battery from a DC supply. We are charging it. Clear? If you supply a 8 volt, if you assume that if you are supplying a 8 volt, now we require a 8 volt here to charge that battery. If you are supplying only the 8 volts, in that 8 volts, some voltage is dropped inside the internal resistor. So that is 8. Now the voltage drop inside the resistor becomes I into small r. Internal resistance becomes I into small r. I is 7, small r is 0.5. That means it is 3.5 voltage is dropped. 3.5 voltage is dropped. Only 4.5 voltage is available for charging a 8 volt battery. So therefore, in order to overcome this difficulty, since we require a 8 voltage to charge this battery and a 3.5 voltage is dropped inside the battery, therefore we require minimum 8 plus 3.5, that is 11.5 voltage to charge that battery. Next problem, in the given circuit diagram, calculate the main current through the circuit. What is the main current flowing through the circuit? Also the current through the 9 ohm resistor. Current through the 9 ohm resistor. The circuit is given. Now assume that a main current I is flowing. Okay. Now here some current I1 is flowing. Assume that here the current I2 is flowing and here the current I3 is flowing. Now this combination is parallel. 3 branch parallel combination agide. Therefore at this junction the current divides. I1 ಹೋಗ್ತದೆ, I2 ಹೋಗ್ತದೆ, I3 ಹೋಗ್ತದೆ. First we have to calculate what is the total current in the circuit. Now here they have given battery of voltage 3, EMF 3 volts and internal resistance 0.24 ohms. Now given solution, now given the EMF of the cell is given, it is 3 volts, 3 volts. Internal resistance is given, R is 0.24 ohms. Okay. Now we have to calculate what is the equivalent resistance, R equivalent, that we are going to work out. Now look here carefully. Now in this branch 3 ohm is in series with 3 ohm. So 3 ohm in series with 3 ohm. Now what is their equivalent? So 3 plus 3, that is equal to 6 ohm. So that means in this branch we can replace these two resistors by a single resistors of 6 ohm. I will write their equivalent in simple manner. Now this becomes a 6 ohm, first branch. Similarly here 6 ohm is in series with the 6 ohm. So 6 ohm resistor in series with 6 ohm. What is their equivalent? So 6 plus 6, it is 12 ohms. Series, in case of series combination, the resistors gets added up. Therefore I will replace these two by a single resistor which is 12 ohm. Okay, and we have the third resistor, so that is 9 ohm. Now this is 9 ohm. Now it is connected to the battery. The circuit reduces to like this. Okay, now these three are in parallel combination. 6 ohm, 12 ohm, 9 ohm, they are in parallel. So therefore 6 ohm, 12 ohm and 9 ohm are in parallel. So their equivalent, what is their equivalent? Since they are in parallel, therefore R equivalent is equal to, it is 1 upon 6 plus 1 upon 12 plus 1 upon 9. Now simplify this one. Now look here, 6, 12, 9, their LCM is 36. LCM is 36, therefore it becomes 6 plus 3 plus 4. That is 13 by 36. 13 by 36. Therefore, R equivalent is equal to, it is 1 upon R equivalent. Therefore, taking the reciprocal, R equivalent is equal to 36 by 13 ohms. 36 by 13 ohms. Or if you calculate that one, I am going to get 36 by 13 is equal to 2.77. 2.769 ಬರ್ತದೆ. So 2.77 ohms ಅಂತ ನಾವು ತಗೋಬಹುದು. If you take, since they have given 0.24, I will write it as 2.76 ohm. 2.76 ohm ಅಂತ ತಗೊಳ್ಳುವ. This is the equivalent resistance. Now what is the current flowing through the circuit? Now this entire circuit reduces to a single resistor, external resistor, like this. Okay, so we have battery. Now here we are having an internal resistor. Now this becomes, that is 2.76, and this is given 0.24, 0.24, and this one is battery of 3 volts. Okay, then we have to calculate what is the current flowing in the circuit. Circuit ಅಲ್ಲಿ ಎಷ್ಟು current ಹೋಗ್ತದೆ ಅನ್ನೋದನ್ನ calculation ಮಾಡುವ. Therefore total current I is equal to, it is EMF divided by R equivalent plus small r. EMF divided by R equivalent plus small r. So EMF of the cell, it is 3 volts divided by R equivalent that we have calculated 2.76 plus this one is 0.24, 0.24 internal resistance, or this one is equal to 3 divided by 2.76 plus 0.24, it is 3. So 3 by 3, that is equal to 1 amps. The total current in the circuit is 1 amps. Clear? Now that is to be divided across the 3 resistors. That is 9. That current is to be divided across the 3 branches. We know by a simple property that since they are connected in parallel, a 3 volts is applied. Parallel connect ಮಾಡಿರೋದ್ರಿಂದ a 3 volts is applied. Now what, since a current of 1 amps is flowing, what is the voltage drop inside the cell? What is the voltage drop inside the cell? Drop inside the cell is equal to, voltage drop inside the cell is I into small r. I into small r. So that is equal to current is 1 into 0.24. That is 0.24 voltage is dropped inside the cell. Therefore terminal voltage, is equal to, so 3 minus 0.24. 3 minus 0.24, that is equal to 2.76 volts. So this amount of voltage is dropped across the terminal. So that means across this branch it is 2.76, across this branch it is 2.76, and across this branch it is 2.76. That one we have got. Then we have to calculate what is the current flowing through the 9 ohm resistor. Therefore, current through 9 ohm resistor. Current through 9 ohm resistor, that is I1 is equal to simple formula terminal voltage V divided by that resistor. V divided by that particular resistor. Now here V, terminal voltage here in this case is 2.76, 2.76 divided by 9. Therefore, I will get, work out that one, 2.76 divided by 9 is equal to 0.30. 0.30 amps of current is flowing through this resistor. ಈ resistor 0.3 amps ಅಷ್ಟು current flow ಆಗ್ತದೆ. Clear? Next problem. Two cells of EMF 2 volts and 4 volt and internal resistances 1 ohm and 2 ohm respectively are connected in parallel so as to send the current in the same direction. Okay, through an external resistance of 10 ohm. Find the potential difference across 10 ohm resistor. Okay, now for that one we will have a diagram like this. Now this is the first cell, 2 volts and internal resistance is 1 ohm. The second cell, 4 volt, EMF 4 volt and internal resistance is 2 ohms, and they are connected in parallel such that they are sending the current in the same direction. They are sending the current in the same direction through an external load resistor of resistance 10 ohm. If that is the case, then what is the voltage drop across the 10 ohm resistor? That we have to calculate. Now it is a case of parallel combination of cells. So two cells are connected in parallel. Therefore, it is the parallel combination. First, we have to work out what is the equivalent EMF and what is the equivalent internal resistance when they are connected in parallel. Then replace this network by a single cell of equivalent EMF and equivalent internal resistance. Then work out what is the current flowing in the circuit. Finally, calculate what is the voltage drop across the 10 ohm resistor. Okay, so solution. Now given, so EMF of the first cell, it is equal to 2 volts and that of the second cell is equal to 4 volts. The internal resistance of the first cell, R1 is equal to, small r1 is equal to 1 ohm, and that of the second cell, small r2 is equal to, it is 2 ohms. What we have to calculate? Very first we have to calculate what is the current flowing through the circuit and potential difference across the external load resistor. They have given capital R is equal to 10 ohm. We know that when two cells are connected in parallel, the equivalent EMF is given by E equivalent. Equivalent EMF is given by E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. That formula we know that one. E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. That we will work out. So E1 is 2, R2 is, it is 2 plus E2 is 4 and R1 is 1 divided by R1 plus R2, that is 1 plus 2. So that is equal to 4 plus 4 divided by 3. So it is 8 by 3 volts. So E equivalent is equal to 8 by 3 volts. 8 by 3 volts. Now what is the resistance? Since they are connected in parallel, the equivalent resistance, I will write here, R equivalent is equal to, it is R1 R2 divided by R1 plus R2. That is the case of two cells, two resistors are connected in parallel. So R1 is 1 into 2 divided by 1 plus 2, that is equal to 2 by 3 ohms. Resistance is, internal resistance is 2 by 3 ohms. Now I am reducing this circuit in a simpler manner. I am having a single cell of internal resistance and it is connected to an external load. The circuit reduces to this one. So now this is E equivalent, its value just we have calculated, and this is small r equivalent, and this one is capital R. Now we will work out what is the current flowing in the circuit. Now the current flowing in the circuit, we know I is equal to, it is E equivalent divided by capital R plus small r equivalent, simple form. Okay, so that is equal to E equivalent, it is 8 by 3 divided by capital R, it is given 10 ohm plus small r equivalent, that is 2 by 3. Now simplify this one. So 8 by 3 means that divided by 10 plus 10 into 3, 30 plus 2, 32. 32 divided by 3. Now 3 get cancels. 3 get cancels. Therefore, I is equal to 8 by 32. It is 1 by 4. 8 by 32 is 1 by 4. That is equal to 0.25 amps. The total current flowing in the circuit is 0.25 amps. What they have asked? Potential difference across the 10 ohm resistor. Therefore, I will write here itself PD, potential difference across the 10 ohm resistor, is equal to, it is simple formula, I into R. Now I is 0.25 into R is 10 ohm. R is 10. So therefore, V is equal to 2.5 volts. Potential difference across the 10 ohm resistor is 2.5 volts. Clear? Next problem. A wire of length 2 meter, diameter 1 millimeter and resistivity 1.963 into 10 to the power of minus 8 ohm meter is connected in series with a battery of EMF 3 volts and internal resistance of 1 ohm. Calculate the resistance of the wire and the current in the circuit. They have given a 2 meter length wire. Now assume it is a 2 meter length wire. Its diameter is given and resistivity is also given. First we have to calculate what is the resistance of the wire. A wire na resistance ಎಷ್ಟು ಅನ್ನೋದನ್ನ first ನಾವು calculation ಮಾಡ್ಕೋಬೇಕು. And then if this wire is connected across a 3 volt battery with an internal resistance of 1 ohm, then what is the current flowing in the circuit? Now these things we are going to work out. Now solution, what are the given things? Now given length of the wire is given, that is L, length of the wire, that is 2 meter. Diameter of the wire, diameter, D is equal to, it is 1 millimeter. Now convert it into meter, that is 1 into 10 raised to minus 3 meter. Therefore, radius of the wire is 1 by 2, that is 0.5 mm, or if you convert it into the SI unit, 0.5 into 10 to the power of minus 3 meter. Clear? Then area of the wire, it is having a circular shape, cross-sectional area. Therefore, area is pi r square. So that is equal to 3.142 into r square. That is 0.5 into 10 to the power of minus 3 whole square. That is the thing. Okay. If you work out this one, we will work out using the calculator. 3.142 multiplied by 0.5 into 0.5, it is 0.25. That is equal to 0.78 into 10 to the power of minus 6 meter square. Now this is the area. Okay. We have got length, we have got area, they have given the resistivity, that is 1.963 into 10 to the power of minus 8 ohm meter. That is given. Now what we are going to calculate? We have to calculate what is the resistance of the wire and what is the current flowing through that circuit. That all things we have to calculate. We know that the resistance of the wire is given by the relation resistivity length divided by area. This formula we are already familiar with that one. Now substituting all the values. Now rho is 1.963 into 10 to the power of minus 8 into length is 2 meter, that is 2, divided by area. Just we have worked it out. So 0.78 into 10 to the power of minus 6. So just simplifying that one, we will get 1.963 into 2 divided by 0.78, 5.03 into 5.03 into, so we will work out the 10 powers, 10 raised to minus 2, minus 8, 10 raised to minus 6. If it goes to the numerator, it becomes 10 to the power of minus 2. Our resistance R is equal to, so 10 raised to minus 2 means it is 0.05 ohms. So 0.05 ohms is the resistance of the given wire. Now when a battery of 3 volts and an internal resistance of 1 ohm is connected, then what is the current flowing through the circuit, that we are going to calculate. Now here a battery of EMF is given, that is 3 volts, and internal resistance small r is given, that is 1 ohm. We have to calculate the current. We are already familiar with the expression for the current. Now current I is equal to E divided by capital R plus small r. Simple formula. Okay. Now that is equal to, so EMF is 3 divided by 0.05 plus 1, 3 divided by 1.05. If you work out that one, 3 divided by 1.05, so I will get 2.86 amps. 2.86 amps of current is flowing through the circuit. Next problem, when two resistors are connected in series with a cell of EMF 5 volts and negligible internal resistance, a current of 2 amps flows in the circuit. When the resistances are connected in parallel, then the main current is 25 by 3 amps. Calculate the resistances. So they have given two resistors, R1 and R2. In the first case, they are connecting in series combination across a 5 volt battery with a negligible internal resistance. Then the current flowing is given, a current of 2 amps is flowing. When the same two resistors are connected in parallel combination across the same cell of EMF 5 volts with negligible internal resistance, the main current flowing in the circuit is 25 by 3 amps. Now these are the given data. Now we have to work out what is R1 and R2, that we have to calculate. Now let me start from here itself, from this side, solution. Now here given, what are the given things? In series, I will take IS. IS is the series current that they have given 2 amps. 2 amps. When a battery of EMF 5 volts is given, first case. Since they are connected in series, what is their effective resistance? It is R1 plus R2. Effective resistance RS, this is equal to RS. Series combination only effective resistance of R1 plus R2 irtade. Now by the simple relation, therefore the current flowing in the circuit is equal to, it is EMF divided by RS. Current flowing is EMF divided by RS, or RS is equal to, so EMF divided by the current in the series combination. So EMF is given 5, EMF is given 5 and current is 2. So therefore RS is nothing but R1 plus R2. I am getting one relation, R1 plus R2 is equal to 5 by 2 R 2.5. All this has some relation 1. Series combination alli ನಾವು ಈ ಫಾರ್ಮುಲಾ ಹಾಕೊಂಡು ವರ್ಕೌಟ್ ಮಾಡಿದ್ರೆ we will get R1 plus R2 is 5 by 2 or 2.5. Now when the two resistors are connected in parallel, for parallel combination, this is for series combination and this is for parallel combination. What are the given things? The main current IP is given. The main current is given. IP is 25 by 3 amps and EMF is given, so that is equal to 5 volts. Okay. Now what is RP in parallel combination? Now RP in parallel combination, we know that it is R1 R2 divided by R1 plus R2. Okay. 1 upon RP is equal to 1 by R1 plus 1 by R2. If you simplify that one, we will get RP is equal to R1 R2 divided by R1 plus R2. So therefore, the current in the parallel combination is equal to, this is the main current, not the branch current, okay, is equal to EMF divided by RP. Therefore RP is equal to E divided by IP. Now E they have given, that is 5 volts divided by IP, current, main current, it is 25 by 3. Okay, so if you simplify this one, 5 into 3 divided by 25, that is 3 by 5 or 0.6. Substituting for RP substitution ಮಾಡ್ಕೊಳ್ಳುವ. Therefore R1 R2 divided by R1 plus R2 is equal to 3 by 5. Now cross multiplying, R1 R2 is equal to 3 by 5 into R1 plus R2. Now 3 by 5, what is R1 plus R2? 5 by 2. It is 5 by 2. Therefore it is 3 by 2 or R1 R2 is equal to 1.5. R1 R2 is equal to 1.5. Therefore R1 plus R2 2.5. R1 R2 is 1.5. Call this as some relation, equation 2. Now we have to solve for R1 and R2. Now we are familiar with R1 minus R2 whole square. R1 minus R2 whole square can be written as R1 plus R2 whole square minus 4 times R1 R2. So the relation is that, so R1 minus R2 whole square is equal to R1 plus R2 whole square minus half 4 into R1 R2. Okay. So our relation ಹಾಕೊಂಡು simplify ಮಾಡ್ಕೊಳ್ಳುವ. So R1 plus R2 is 2.5 or 5 by 2. 5 by 2 whole square. 5 by 2 whole square is 25 divided by 4 minus 4 into, what is R1 R2? R1 R2 is 3 by 2. It is 3 by 2. Okay. So therefore 25 by 4 minus 6. So simplify this one is equal to 25 minus 24 divided by 4. It is equal to 1 divided by 4. 1 divided by 4. Therefore R1 minus R2 whole square is equal to 1 by 4. R1 minus R2 is equal to 1 by 2 or R1 minus R2 is equal to 0.5. R1 minus R2 is equal to 0.5. Now call this as some relation 3. Now we have got 3 relation, R1 plus R2 2.5, R1 minus R2 0.5, R1 R2, that is the second equation, this is 1.5. So from 1 and 3 we can obtain the value of R1 and R2. So just adding equation 1 plus equation 2. If you add them, you get R1 plus R2 is equal to 2.5. R1 minus R2 is equal to 0.5. Adding R2 get cancels. Therefore, 2R1 is equal to 2R1 is equal to 3. Therefore, R1 is equal to 3 by 2, that is 1.5 ohms. So, R1 we are getting 1.5 ohms. From the equation 1, if you substitute R1 is equal to 1.5, therefore from equation 1 we get R2 is equal to 1. Therefore, the value of the two resistors is 1.5 ohm and 1 ohm. If you are adding, you will get 2.5. If you multiply, you will get 1.5. Okay. Next problem. Three resistors, 3 ohm, 4 ohm, 12 ohm are combined in parallel. What is the effective resistance of the combination? B. If the combination is connected to a battery of EMF 6 volts and an internal resistance of 5 ohm, find the current drawn from the battery and the terminal potential difference across the battery. In this problem, we are having two parts. The first part is as shown in the diagram. The three resistors are connected in parallel, 3 ohm, 4 ohm, 12 ohm. First, you have to calculate what is their effective resistance. What is their effective resistance that we have to calculate. Okay. We'll start here itself. The solution. So, given R1 is equal to 3 ohm, R2 is equal to 4 ohm and R3 is equal to 12 ohm. These are the given things. First, now their equivalent is RP. Parallel combination RP is equal to question mark. So then we know that the formula 1 upon RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, very simple. Substitute and simplify. Now 1 by 3 plus 1 by 4 plus 1 by 12. Now I will do here. Now 1 by RP is equal to 3, 4, 12. Their LCM is 12. 12 is the LCM. Then 3 4s are, therefore 4 plus 4 3s are 3 plus 12 ones are. Therefore 1 by RP is equal to, it is 8 by 12. Therefore we want RP. Take the reciprocal of that one. Therefore it is 12 by 8. That is 3 by 2 or 1.5 ohms. 3 by 2 or 1.5 ohms is the equivalent resistance of the parallel combination of the three resistors. Clear? Okay. Next part. If a battery is connected across this combination, we are connecting a battery here with a small internal resistance across the combination. Across this combination, a small internal resistance of 0.5. It is 0.5 ohms internal resistance of a battery of 6 volts. A battery of 6 volt. EMF 6 volt is given. Then we have to calculate what is the current flowing. Find the current drawn from the battery. We have to calculate what is the total current. Here we have to work out only the total current and the terminal potential difference. That those two things we are going to work out. Now here given, for the second case they have given EMF is 6 volts. EMF is 6 volts. Internal resistance small r is equal to 0.5 ohm and the capital R, RP that we have just worked out, that is 1.5 ohm. Next we have to calculate what is the current and what is the terminal potential. Clear? Now for the current we have simple relation. Now current is equal to EMF divided by capital RP plus small r. Okay. Now EMF is 6 divided by RP is 1.5 and small r is 0.5. That is equal to 6 by 2. Therefore, current is equal to 3 amps. Therefore, the circuit draws a current of 3 amps from the battery. Now, last one, terminal potential. Terminal PD. That is voltage across the terminals of the battery or voltage across the parallel combination of the three. So, that is obtained. Terminal potential capital V is equal to the main current I. It should be is equal to the main current I and multiplied by the equivalent resistance in parallel combination, that is RP. Equivalent resistance in the parallel combination. So main current is 3 and equivalent resistance is 1.5. Therefore, terminal voltage is 4.5 volts. Okay. Now here once again look at this one. Now this is the EMF of 6 volts and this is the terminal potential difference. We are applying 6 volts, but across the combination of the parallel combination we are getting only 4.5 volts. Now where is the remaining 1.5 volts? Now it is dropped inside the cell. That 1.5 voltage is dropped inside the cell because of the internal resistance of the cell. Okay. Next problem, calculate the current density and average drift speed of the conduction electrons in a copper wire of cross-sectional area 10 raised to minus 7 meter square carrying a current of 1.5 amps. Given free electron density of copper is 8 into 10 to the power of 28 electrons per meter cube and charge of the electron E is equal to 1.6 into 10 to the power of minus 19 coulomb. Okay. So, very simple one. So, solution. First we list out what are the given things. Given cross-sectional area of cross-section A is given. So, 10 to the power of minus 7 meter square. And current flowing through that copper wire is 1.5 amps. And a free electron density, that means the number of electrons per unit volume. Number of electrons per unit volume. So, that is given. So, 8 into 10 to the power of 28 electrons per meter cube. So, that is given. Charge of 1 electron is given, that is 1.6 into 10 to the power of minus 19 coulomb. What we are going to calculate? We have to calculate what is current density and what is the drift speed, magnitude of the drift speed. Those two things we are going to calculate. Now, we are already familiar with the definition of current density. What is current density? It is current per unit area is called current density. Therefore, current density J is equal to I by A. Simple formula. Now, substitute the value of I and A. Now, I is 1.5 and area is 10 raised to minus 7. 10 raised to minus 7. So, therefore, J is equal to 1.5 into 10 raised to plus 7 ampere meter square. Ampere meter square. Value of J. Next, drift speed. For that one, we have an expression for current in terms of drift velocity. Expression for current in terms of drift velocity. I is equal to N E A. So, magnitude of the drift speed Vd. N E A Vd. N is the number of electrons per unit volume. E, charge of the electron, A, area of cross section, and Vd, that is the drift speed that we are going to calculate. Therefore, drift speed, magnitude of the drift speed is equal to I divided by N E A. Now I by A we have worked out, that is nothing but J, or this can be written as J divided by N into E. Clear? Now J they have worked out, we have worked out, that is 1.5 into 10 raised to plus 7 divided by N, number of electrons per unit volume, 8 into 10 to the power of 28 they have given, multiplied by charge of the electron 1.6 into 10 raised to minus 19. Okay, so we will simplify that one using the calculator. 1.5 divided by 8 divided by 1.6, 0.117. So drift speed, magnitude of the drift speed is 0.117. Now simplify the powers. Now here 28, here is 19. Therefore 10 to the power of 28 minus 19, it is 10 to the power of plus 9. If you take it to the numerator, it is 10 to the power of minus 9. Here it is plus 7 into 10 to the power of minus 2. 10 to the power of minus 2. Ten to the power of minus 2. Our drift speed is equal to 1.17 into 10 raised to minus 3 meter per second. 1.17 into 10 raised to minus 3 meter per second, or 1.17 millimeter per second. So 1.17 millimeter. So therefore the drift speed is very small. It is about 1.17 millimeter per second. Now this drift speed is very small compared to that of thermal speed of the electrons. Next problem, two resistors of resistances 12 ohm and 6 ohm are connected in parallel to a battery of 12 volts. Calculate the equivalent resistance of the network. Obtain the current in 12 ohm resistor and 6 ohm resistors, that is branch currents. Okay, the network is as written here. Now 12 ohm resistor and 6 ohm resistors are connected in parallel, and they are connected to a battery of 12 volts EMF and negligible internal resistance. Very simple then. So solution, given the first resistor R1 is equal to 12 ohm, the second resistor R2 is equal to 6 ohm. Okay, the battery of EMF is 12 volt and their internal resistance is negligible, that is 0. Now we have to calculate what is their equivalent resistance Rp, what is the total current flowing, and the individual currents I1 and I2. Those we are going to calculate. Now since the resistors are in connected parallel, the effective resistance in parallel combination is simply R1 R2 divided by R1 plus R2. That is the formula we are using. Okay, just to substitute and simplify. It is 12 into 6 divided by 12 plus 6, that is 12 into 6 divided by 18. 1s are, 3s are, 4s are. Therefore Rp is equal to 4 ohms. The equivalent resistance is 4 ohms. Next, the currents through the individual resistor is calculated in two ways. Since these two are connected to a 12 volt EMF with negligible internal resistance, the same 12 volts is dropped across the individual resistors because they are in parallel combination. By using that relation, we can find I1 and I2. V is equal to I1 into R1. Therefore, I1 is equal to, V divided by R1. Now V is, it is 12 volts divided by R1 is 12. Therefore 1 amp of current is flowing through the first resistor. 1 ampere of current is flowing. Similarly, the potential drop is same because they are in parallel combination. We can write I2 into R2. Therefore, I2 is equal to V by R2. I2 is equal to V by R2. So, therefore, that is equal to V is 12 divided by R2 is 6. That is equal to 2 amps. 2 amps of current is flowing in the 6 ohm resistor. Okay. There is no need to work out total current, or if you can calculate the total current. So in some other problems, if they have given an internal resistance, then the potential drop and EMF not at all equal. The terminal voltage and EMF are not at all equal if the internal resistance is present. In that case, what we have to work out? We have to work out the current and the drop across the combination and then follow this method. Okay. So total, how do you work out total current? Now in this case, total current is equal to EMF divided by RP. Now EMF is 12 divided by RP, just we have calculated, it is 4. Therefore total current is 3 amps. Now here we have worked out 1 plus 2, that is 3 amps we are getting. So remember, how can we use a branch current formula? So branch current formula, so current in the first resistor I1 is equal to main current into other resistor, that is R2, divided by sum of the resistors. By using this formula also, we can work out what is I1. Similarly, how can I write for I2? Now, branch current I2 is equal to main current into other resistor, that is R1 divided by R1 plus R2. By using those relations also, we can calculate what is I1 and what is